and just things that interest me and things, and hopefully get other people on to chat about their interests in technology as well. So it's just, you can get it there, but it also is on Amazon, Spotify, all that normal kind of stuff. This is what I do most of the day. I look after the asktom.oracle.com website. Most people are aware of that. This is one thing that maybe some people are not aware of, is we have a whole lot of people inside Oracle that are experts in their particular fields who don't get the luxury of that I get of actually meeting people out in the field. So we wanted to make those people available to customers so they could be more successful. Ask Tom Office Hours is regular monthly Q&A sessions with experts inside Oracle. Because we have a lot of different topics and fields of expertise, that averages out to be about 2 to 3 per week. They're all recorded. You can watch them after the fact, but it's a great way of meeting up with specialists in particular product areas of the Oracle database. Now, before we begin, I've been saying this for the last 18 months. While I do enjoy being able to reach out to user groups around the world because of the virtual platform, let's face it, we are all desperate to get back to face-to-face events. So follow your local laws, your local guidelines, your local mandates. Let's get ourselves vaccinated so we can get our communities back in face-to-face environments. I'd love to actually be in Latvia as opposed to talking to Latvia. Hopefully 2022 will be the next way we can do this. The big question is, why talk about SQL? I mean, let's face it, SQL is pretty old, and it's an interesting topic. Normally when we talk about languages, we talk about brand new features or new languages coming out, etc. But SQL is not that. SQL is very, very old. In fact, if you look back at the very first version of Microsoft Windows, SQL is older than that, because SQL is just coming up to 40 years old. Windows came out around 1985. SQL predates that by nearly a decade. So in terms of languages, it's one of the oldest ones out there. And let's face it, you don't see a lot of talks nowadays about Fortran or COBOL. So why talk about SQL? Here is my driving reason for always including SQL in the topic of conversation when it comes to the Oracle database. In the good old days, you would have a database and a program that spoke to it. Nowadays, application development has become this incredibly abstract art. You have multiple layers in the stack, browsers and app servers and connection pools and so many things going on, and ORMs, etc. But reality is, underneath all of those layers, in the middle of the onion still, is the database. And if you have bad SQL, then that just flows throughout to the outside world. You cannot get around a slow SQL with any other kind of thing in your application stack. Now, one thing I want to point out in this session, there's 2 key points I want to really focus on in this session before we talk about some SQL features. Number one is, yes, this is about SQL techniques and tips and tricks, but it's not about me being a smartass. I didn't want to have a set of slides where it's just realms of incredibly complicated SQL showing off how wonderful SQL is, because it's not really useful. We want things that are actually genuine, that you can use tomorrow in your workplace. So the reality is, we can do pretty much anything in SQL. And in fact, let me give you a simple example of the things we probably won't talk about or dwell on too long today. Here's the first page of a piece of SQL. Here's the second page of a piece of SQL. I didn't write it. It was written by a good community friend named Anton. What does this SQL do? Well, most of you are probably familiar with the game of Sudoku. If I could take that visual representation of Sudoku board and turn it into, say, a simple string, something like that, that's the same thing, just with some dots and some vertical and horizontal lines, that SQL statement you just saw will solve it. Now you might be thinking, is that really true? Where's the proof of that? So let's bring up a window and we'll give it a go. Let's get rid of, I was just looking at DBA users before. Let's fire up. There's the first page up there. There's the string we came in. There's the first page of the SQL statement you just saw before. There's the second page. Let's run it. And voila, there's the solution. Now, even that might not really convince you that something is actually being really solved. I might have just hard-coded that solution in. So what I'll do is I'll take out the terminating condition so we can see the SQL actually doing its work. Now, if we think about a Sudoku board, it's 81 digits. So I take that nice sort of pictorial version, convert it into a single 81-digit string, and what this SQL does is just brute force works through all the permutations. It's obviously very fast, but you can see it's slowly filling in all the blanks, working its way from left to right. And eventually, when we finally get to all of the numbers filled in, I just reformat it to actually come out nice and simply and elegant to look at. But that's all it is. This is a SQL statement that will solve Sudoku. Don't get me wrong, I'm confident at the end of this session, we'll show you all these really useful techniques for your workplace, and you'll come back to me and go, I just want the Sudoku SQL. I understand it's cool and it's cute, but let's move on. Here's another example of a SQL statement that looks incredibly complicated. What does it do? It draws the Mona Lisa. So this is perhaps a more artistic use for SQL. But let's be realistic. The percentage of us as developers that need to solve Sudoku or show the Mona Lisa as part of our regular job is exceptionally low, I would imagine. The reality is our job is getting real stuff done, solving business requirements, functionality requirements that come in from our customers. And the vast majority of customers aren't asking us to solve Sudoku. The second key point before we talk about SQL techniques is a little bit of controversy. If you want to be a successful SQL practitioner, you also need to be friends with your DBA. And as developers, and DBAs, often there's a bit of a chasm between those two groups in an organization. And it's not just often a philosophical chasm, it's actually can sometimes be a geographical one. It's sad that often DBAs sit in one part of the building, developers sit in the other part of the building, or DBAs sit in one country, another country, or even continents. We have such a global connected world nowadays that separation is getting longer and longer. There's also some cultural chasm sometimes between. You ask your average developer what they think of a DBA, and they often say, oh, the DBA is that old dude who sits in the corner somewhere. They got strange taste in footwear. They drink old person's drinks. There's a bit of a cultural friction there. And conversely, you ask the DBA what a developer is, and they go, oh, it's those Red Bull drinking, Justin Bieber loving, don't know how to wear their jeans properly, sort of millennials, etc. There's often tension and friction between developers and DBAs. That is a recipe for application disaster. That relationship between the people that design your database and the people that code for your database is really, really important. And let me try prove that to you with a simple SQL statement. I'm going to create a table here called My Transactions 1. We're simulating some customer transactions in some sort of sales application we've written. So we can see we've got customer IDs, we've got a transaction ID for every transaction that comes in, a transaction date, etc. It starts off as empty, and I'll put 200,000 rows into it. Tab 200K there is just a table of 200,000 rows. It's just a nice, easy source. We can see our customers are randomly distributed between 1 and 100. We've got random transaction dates and random transaction values, but it's just random data. Let's now see the cost it takes to query all the rows for a single customer. Let's run that customer. The first query, the key stat here we're interested in is consistent gets. We can see it took 514 IOs effectively, they're logical IOs because this table's small enough to fit in memory, to actually find all the transactions for that customer. Now, there's a cost to running a query for the first time. The second time I run it, it's a bit better. It's 378 because the database now knows how to run that query. It didn't have to run queries of its own benefit to find out the columns, the attributes, the security privileges, etc. But once it knows that, that 378 is constant. That's the cost of running that query. I run it again, still 378, again, still 378, etc. It doesn't change. That's what it costs to get that one customer's transactions from My Transactions 1. Let's now create My Transactions 2. It's the same table, same columns, same data types, same everything. It starts off as empty, just like My Transactions 1. I'm going to copy the rows from My Transactions 1 to My Transactions 2. They have the exact same data. We can prove that. How many rows are in each table? Exactly 200,000. I can do a minus query to compare the data. There's nothing in My Transactions 1 that's in My Transactions 2, and there's nothing in My Transactions 2 that's in My Transactions 1. They have exactly the same data. They've got exactly the same indexes here. There's no magic and sneaky tricks up my sleeve here. They've both got a primary key of customer ID and transaction ID. Let's refresh our memory. What does it cost to get a customer's information from transaction 1? Still 378 consistent gets. Let's now get customer 160 from my transactions 2. Same table, same data, same distribution, same indexes, 99 consistent gets. And let's not forget, that table, that query is the first query. That's the most expensive query we'll ever run. Now that the database knows how to access my transactions 2, now it's 18. From 378 to 18 is 20 times faster, and that is repeatable. So same table, same data type, same data, same data in it, 20 times faster queries. That's why that relationship with the DBA is important, because if you can convey with them the things that are important to you, which queries are the most important to you, the database can be tailored to solve those particular needs. So I'm not going to go into well on how we did that, but it's important to realize that data structures are important. The way I thought we'd talk about SQL features for the next 45 minutes or so is to talk about like a typical weekend as a parent. But I'll basically convert that weekend to being SQL edition. So how does my weekend start? It's my first son, Max, going, I need to be taken to basketball. And I quite like watching basketball. When he plays, though, all they show up on the scoreboard is just the total scores. So I thought what I'll do is while I go along to his games, I'll whip up a little application in Apex that I can run on my phone, just using one of our free cloud environments. And every time a player scores, I'll log what they score. So rather than just having the total points at the end of the game, I have some nice information. For each quarter of the 4-quarter game, I can see Campbell scored a point from the free throw line, Robbie scored a 3-pointer, Zach scored 2 points, etc. My son's Max got himself a 3-pointer. So it's just a nice way of collecting more data that the players might be interested in, and same the coach. Rest assured, this is still, this is not professional basketball. This is more just for the interest of the parents and the players. There's nothing really, going on here. But as a result, you start getting inquiries. The coach says, look, that's pretty cool. Could you give me like the point spread for each player? But also I want the quarter by quarter totals to see how we're going at each quarter and the grand total. Now to do that in SQL, well, I can do one query that gives me all the points for each player. I can do another query that shows me the quarter by quarter totals. I can see I got 40, first quarter was a great quarter for us. Then I can run another query to get the grand total. But that doesn't seem a really intelligent way of doing it. Why would I run 3 queries to satisfy one functional requirement, which was that? There's the requirement from the customer. I don't want to have to run 3 queries to satisfy that one requirement. I can get from 3 down to 2 pretty easily using a rollup. Here's my first query, still just getting the raw data out of the data. Here's my second query using GroupByRollup. Rollup is cool because it gives you multiple levels of aggregation. In this case, by using rollup to the quarter, I've got the quarter by quarter totals and a grand total. Getting from 3 to 2 is good, but it's still a bit messy when it comes to actually putting that out to my application. If I'm writing this as a report, I've got 2 data sources, and I need to now merge that into some sort of final output. So I put the raw data in first, then I need to know that I've run out of quarter 1 data, so now I put in the subtotal, then I move on to quarter 2, and so forth. I need to sort of, walk through each result set and sort of splice it all together. That's more complexity for me in code. At which point people often say, that's all just too hard. I'll just throw it into Apex or some other, reporting tool and let it do it. The problem with that is these reporting tools have to be all things to all people. They have to satisfy all sorts of functional requirements. If you put a trace on Apex, which is probably one of the better tools, but any other reporting tool as well, you'll see what typically happens is they do some of the calculations in SQL, but then what they do is they fetch through those result sets and they take on the work of splicing that all together. That's more complexity for the tool, more CPU costs for you. We'd rather be able to do it with just one SQL. So can we get from 2 down to 1? And yes, we can. We know that RowNum is a unique value assigned to each row coming out of the result set. So if I group by rollup with the quarter and RowNum, I'm actually doing subtotaling at the grand total level, the quarter level, and at the individual row level. So by incorporating RowNum into my rollup, I now get the player data, I get the quarterly subtotals, and I get the grand total. It's all presented in a nice, correct order, and I've done it with one single pass through the data with one single query. It's a nice, cool way of exploiting rollup to get multiple levels of subtotals. If you're into generating various kinds of totals, Oracle has plenty of those extensions. You can use GroupByCube. GroupByCube looks at the attributes you pass to the cube, in this case quarter and player, and comes up with every permutation. So I get the quarter and player subtotals. Then I get the player subtotals. Then I get the quarter subtotals. And finally, I get the grand totals as well. So you have this power to get every potential subtotaling permutation out of the cube. If you like it to be a bit more focused, you might want to choose exactly what totals you want. You also have that totally customizable flexibility. You can use the grouping sets facility to explicitly nominate. I want totals by player first. In fact, I've highlighted the wrong one then. It's totals by quarter. We need to flip that highlighting around, and then the grand total as well. But grouping sets lets you explicitly nominate these are the aggregation levels I want. The cool thing with that is, if you're wondering how Apex does its fantastic facility called faceted search, this thing on the left here, we use our own facilities. If you put a trace on an Apex report, you can see it's using grouping sets to work out the various attributes for the facets in faceted search. We, what's the term? We eat our own dog food. We use the features that we built to actually make sure that Apex is as efficient as possible. Once people start realizing that I'm capturing information on the game, well, then the parents start getting in touch and they're sending me emails like this. Hey, Connor, I saw the report you gave to the coach from the game. It would be cool if we can get that information broken down for each player. Now, whenever a parent sends me a text or an email saying each player, what they really mean is their son. And that's fine. We're all parents. We all like getting information about our own kids. So if I'm trying to do a breakdown for each player, if I want to get, for example, information on a quarter by quarter basis, well, it's easy to synthesize the 4 quarters of the game using a select from dual with the familiar collect by level trick. And here's the information from the actual quarter by quarter totals for each player. I want to bring those 2 result sets together to give a summary by player. If I'm looking for player results by quarter, your inclination might be I can just use a conventional outer join for that. So I'll bring together that 4 rows for each quarter and the player by player quarterly totals and just use a simple outer join. It looks like it's giving me all the data, but if we look a bit closer, the problem is we still have this issue of sparse data. If we look at, for example, a highlight in green here, Matt, one of the team players, and Max, my own son. Matt didn't play or didn't score in the 3rd quarter. So even though it's an outer join, we only get results for 1, 2, and 4. A conventional outer join, because Campbell did play for all 4 quarters, that's sufficient to match all 4 rows in our second table here, which means these guys are all going to miss out. We get 1, 2, and 4 for Matt, and 1, 3, and 4 for Max. So even though it's an outer join, we're not getting all the sparse data filled in. The issue with data being sparse is once we start doing things like outer joins, we're not guaranteed to get a row for every single player. We're guaranteed to get at least 1 row from that quarter table for the whole result set, but not once for every single player. The issue with that, though, is how do I know how to put this quarterly table in for every single player? I almost need to repeat that entry in the join once for each distinct player in my result set. And of course, depending on how many players in the team play on a certain day, I don't really know that in advance. I know what's more, I don't want to write that join if I've got 8 players. I don't want to put that table there repeated 8 times in the join. That's where our partition data join, which has actually been available for a long time, becomes very, very useful. Simply by adding this partition by clause, in effect, I'm telling the database that the outer join target, this one here, needs to be repeated once for each distinct player because I'm partitioning on that clause. So now I get the quarter table repeated for Campbell. Here he had 4 rows anyway, but now I get the 4 rows repeated for Matt and the 4 rows repeated for my son Max. You can see here that he didn't get any points in quarter 2. He either didn't play there or didn't score. I'm just using an NVL to map it to 0. The big question that comes out of this, of course, for me is, why isn't my son on the court in quarter 3 or quarter 2? That's what I'll be asking the coach. But you can see partition data join, a great way of inflating data. Once you've got data like that, it becomes very, very easy to render on a report. Normally, one of the things that often confuses end users or customers of reports is if data seems to be missing in these kind of, what do we call them? Break reports, column break reports. The problem here is if they don't see 4 rows for every single player, they start to panic. That's where partition data joins can be very, very useful. Excuse me. Then Mary, our coach, drops him an email saying, we've got a new boy. He's looking at joining the team. We don't know much about him, but let's assume he's averaging 13 points per game. How would he fit in? How does he fit into the team structure if he's averaging 13 points per game? Normally what we would do when we're asked about data that doesn't exist, this player doesn't exist in our team yet. We don't have any data on him in our table. We just have this hypothetical information about him. So often what people will do if they don't have the data in the table they're interested in, they'll query the data they have and they'll just sort of eyeball it. They go, okay, yeah, well, he'll get less than Will, he'll get less than Campbell, he'll get a little bit more than Robbie, etc. That's obviously a painstaking and not very scalable way of doing hypothetical analysis. Hypothetical analytics is actually there in the database for us. Even if we don't have data, we can present data to it and compare it to existing data in the database. In this case, because this incoming player averages 13 points per game, we can write clauses like this. We can say, what would the ranking be for 13 points, ordering by points, based on the existing data in the table? And this one says he would rank third. Because I've done order by points, he would be the third lowest. Lowest point would rank once, etc. So he would be the third lowest scorer in the team if he averages 13 points per game. Now, of course, you might be thinking, well, with only 8 players, it'd be just as quick to, rather than write the SQL, I could just do the eyeballing of that. But that hypothetical analytics obviously has all the power of SQL behind it. So if he's averaging 13 points per game, we might say, well, what if he's getting about 4 points per quarter? I can easily change my SQL to now get a ranking by group by. Because the rank has a within group clause, simply adding a group by extends that existing SQL to get more information. We now know that if he averages 4 points per quarter, he would be our 5th lowest based on quarter 1, our 4th lowest on quarter 2, etc., etc. Very flexible, and in particular, we're using data that doesn't actually exist in our table to still gain some analytical advantage out of our data set. When the basketball's over, you would think as a parent you would come home and relax, but of course that doesn't happen. My second son, Aiden, is then saying, I need to be taken to his football game. Now, football I should get the nomenclature right here. I'm not referring to football that we play in Europe. I'm not referring to soccer as they refer to it in the United States and sometimes Australia. I'm referring to what we call Australian rules football. And if you've never seen Australian rules football, you can think of it as a fairly violent version of keepy-off. But there's my son there in the white. He's a ruckman in his Australian rules football team. Australian rules football is taken perhaps a bit more seriously. It's probably our national sport. And so we start getting a few more detailed questions from the coach. For example, we start getting things like this. Find the total goals scored by each player. And then with the average of those totals, those players who got above that average, we're starting to get these much more complicated requirements. And of course, as application developers, our job is to convert that into a SQL statement. One of the cool things about the Oracle database is when it comes to tackling tougher challenges in SQL, one of the things I love doing is using what we call common table expressions, otherwise known as the with clause. The with clause in its simplest form is just a way of giving a meaningful name to a SQL, a subset of SQL. So in this case, here's a very simple, show me the goals by quarter from my table. If I want to give that a meaningful name, I can simply say, yep, from now on, I can refer that to subtotals. It's like an on-the-fly view defined in the database. At which point you're going, well, what's the benefit? I started with 3 lines of code. Now I've got 6 lines of code and I've got the same result. Isn't that just wasting my time? Isn't that just more effort on my part? The reason I love the with clause is it's a great mental model for us as developers when we're coming to tackling relational problems. Don't get me wrong, I'm a huge fan of relational databases. It's the most rigorous, probably algebraically based database model out there. It's obviously the dominant model. The vast majority of applications run on relational databases, but it can be pretty complicated to write, to satisfy complicated customer requirements with a single SQL statement. Now, don't get me wrong, I'm not blaming us. I'm not saying that we're ignorant or stupid or unintelligent as developers. I blame this guy, Mr. Cod, who invented the silly thing. I mean, you read the relational theory paper and it's got data is represented as mathematical n relations, and n relation being a subset of the Cartesian products of n domains. I don't know about you, but when I read that, I had no clue what that meant. When I first got into databases, I thought databases were just Excel but bigger. So as developers, we often don't take relational approaches to problems. As human beings, we generally try to break down complicated problems into smaller problems and take them step by step. And that's what we can do with the common table expressions or the with clause. I can take that complicated requirement and tackle it one step at a time. The first line was, find the total goals scored by each player. I can write a query just for that. That's easy. There's my query, and I'll call it player total. Then it says, find the average of those totals. Well, that's cool. I've got a table now called player total. I can just do an average of that. And that's the second part of the query, satisfied. And finally, it says, list those players who got above that average. That's easy as well. That's just a simple join between these two tables. Bring it all together, and there's my final query. I really like this because we took a programmer's approach to the problem. We said, let's break it down into small, bite-sized chunks, tackle them one bit at a time, but we still ended up with a single SQL and a relational solution. It's the optimizer's problem now to come up with the best way of running that. That's the joy of the with clause. And what's more, I would argue that queries that are written like this are helping the next person who comes along to maintain your code. It's almost like a picture of your thought process as to how you built up the solution to this challenge. The other great thing with the with statement is it becomes fantastic for code reuse. Let's face it, the days of applications always returning rows and columns to the client is perhaps disappearing. Nowadays, every application out there is demanding that its results come as JSON. So let's go back to for example, our partition outer join query that looked something like this. This may have been written for a client-server application, say Oracle Forms or something, where we come back as rows and columns, but now we need to provide that information as for example, web service call. Rather than rewrite it from the ground up, I can simply say, well, that's my raw data, take the raw data, and then use some of the JSON facilities we have in the Oracle database to recast that result as a JSON array. So when it comes to refactoring your code as modern application requirements change, rather than have to rewrite from scratch, the with clause is a great way of reusing SQL and evolving it over time to meet the new demands of application development. So the basketball's finished. The football is finished. And of course, you take them home. Do you think I get a break? No. They're going, I'm hungry. And of course, teenage boys need feeding and they need a lot of it, which means I'm on my way to the shops to pick up a lot of food and other grocery items. The challenge for me is as I get old, and because I'm a computer guy and I sit down all day and don't do the right things in terms of posture or exercise, I get a sore back. So I want to make sure that when I'm loading my bags, the shopping, I'm trying to make sure that I want to divide that shopping equally by its weight into the 4 bags, such that as I'm carrying them, I'm not going to do myself an injury. So if I look at my shopping that I've recorded in my table here, I've got weights in grams, of course, because we use metric, weights in grams, and there's my 4 bags. I need to come up with a mechanism of distributing those weights such that each bag adds roughly the same weight to give myself a best chance of not doing myself some back injuries. SQL can even tackle these kind of challenges. What I'm looking for, and I'll build this up and bit by bit, I'm looking for a pattern. I'm looking for a pattern that matches 4 bags worth of weights. And I need to decide how I'm going to load these bags. I've got 4 bags and they're matching as yet unknown rules. I'm trying to come up with an algorithm which is going to load these bags equally. So if I've got 4 bags to start with, which bag shall I use with my first item? Well, probably the first thing is if a bag is empty, I should probably use that straight away. So if there's nothing at the moment in the bag, let's put the next piece of shopping into that bag. If the bag does have something in it, well, if it's currently weighs less than all the other bags, then it's probably currently the lightest bag. Let's put the next item in that. So I'm going to slowly add sort of round robin through the bags such that I've always looked at the lightest one and put the next item in that. I repeat that rule for the other bags as well, and I end up with a query that looks like this. This is called a pattern matching clause, and the key thing is the word match recognize, which identifies it as a pattern matching query. I've brought the entire rules and pattern in here together, and when I run it, I get this result. That probably looks a little bit cryptic, but as we walk our way down this list, we can see that the bag, I started off with the first element in this bag, the second element went in bag 2, the third one went in bag 3, and then we started working our way down, picking the lightest bag as we went. So when we finally got to the last row, we can see the bags are relatively evenly distributed. Now, how do I turn that into my list of items to put into which bag? I can take that original query I just had, I can reuse it by using a with clause as we just saw, and I'll use another facility called the listAgg function. ListAgg simply concatenates items based on a grouping mechanism. Using listAgg, I end up with this result. In bag 1, I should put my butter, deodorant, eggs, and my gin. Bag 2, apples, honey, ketchup, soda, steak, etc. And we can see the weights are fairly nicely distributed. I'm not going to do myself an injury, and most importantly, I should be able to get my gin home nice and safely. At which point you're going, at the start, Connor, you said the code was going to be easy, it wasn't going to be complicated, and you've just given me a 1-minute whirlwind tour of this 2-page behemoth. This is true. I will concede that writing pattern matching queries is a somewhat intermediate to advanced activity, and maybe not everyone on your team is going to have the time to learn and practice those facilities. Or you might be saying, yeah, thanks for that SQL that works for 4 bags, but how on earth do I change it for 3 bags? How do I change it for 5 bags? In fact, what if I don't even go shopping? What if I want to put my hardware items into multiple bags? How do I adapt the query for that? All these things add to a lot of code activity, a lot of code maintenance going on, which perhaps isn't suited for your team if they don't have a lot of SQL expertise. That's where, keep an eye on the time here, yep. That's where SQL macros have come into Oracle, and they are very useful for meeting that demand of masking complexity whilst providing plenty of flexibility. SQL macros you can think of as SQL that can actually write or modify the SQL you provide to the database. You can think of it like as a view on steroids. A view obviously is something statically defined in the database. A SQL macro is similar to that. It's taking a SQL you present, doing changes to it, transforming it, and then doing this all on the fly, and then presenting it to the database for execution. So I'm creating a function here called pack and carry. And obviously there's a lot to unpack here, no pun intended, and we're not going to spend a lot of time on it. But the key thing is it takes a couple of parameters. It takes in a table name, and it takes in a number of bags that you might want to divide your shopping over. There's a fair bit of sort of iteration and stuff going on here, but probably better if I just skip to the next part of the application, which is this. You can see we're building up a SQL statement, and I've got a few sort of keywords here. I've got some hashes and some dollars and some tildes, and I'm replacing them with some of the components I built up on the previous slide. I'm dynamically building that complicated pattern matching query we saw in our first example with the shopping. Once that is dynamically built, that automatically gets passed to the database engine for execution. As a result, I can now run my original example by simply selecting from pack and carry. I want to do pack and carry from the shopping table with 4 bags, and I get my exact same result as before. I want to actually now do 3 bags. Did I have to rewrite the SQL? No, all that complexity was held in the SQL macro. Dividing it over 3 bags, it just becomes change the 3 here, and I now get 3 bags with different items, different weights. I can dynamically change the table name. I don't want to go to the shopping. I want to go to the hardware store, and I've got 5 bags. And now with the 5 bags, the first bag has a chainsaw, second bag has a power washer, etc., etc. All that flexibility is now being pushed into the macro, and I can expose this to the rest of my application development team, or I can expose it to end users, etc. I can build Apex applications with it, etc. But that complexity is now centralized in one place. And the best thing with SQL macros is you don't have to worry about the normal things you'd be concerned about when you're using dynamic SQL. The way SQL macros are crafted is you cannot do SQL injection even though we are dynamically building SQL statements. The database takes care of that for you. So we've done basketball, we've done football, I've fed the damn children. Finally, I get a bit of me time. And when I want to sort of decompress on the weekend, sometimes I like just to go to the local pool and swim some laps. Now, I'm not a great swimmer, so for 50 meters, I'm trying to average about 1 minute per 50-meter lap. And for me, it's all about consistency. I'm trying to get into the zone. So with each lap, I'm trying to sit on about 60 seconds. The thing I'm interested in is how close do I keep to 60 seconds? Or if I can't keep every lap on 60 seconds, how can I get to an average of 60 seconds for as consistently as possible? So here's my sort of recorded some data from my swimming. And you can see I'm reasonably happy with that result. Across all the laps I swam, I averaged about 59, just under 60 seconds. So across the entire session, yeah, I sat on about 60 seconds, but that doesn't really give a measure of variability. I might have done 6 laps at 65 and 6 laps at 55. And that's not what I want. I want, in terms of building my endurance, I want to sit as close to 60 seconds on each one as possible. So I want to query how often I'm on track. And I can do a bit of eyeballing here and sort of look at some deltas. For example, if I look at the delta here, I was 1.3 seconds under, 0.3 seconds under, then 0.3 seconds over, and 1.3 seconds over. If I add up the deltas away from 60, I can see I sat on 60 exactly for those 4 laps if I sort of look at the deltas and average it out. Similarly, from laps 9 to 12, I did the same thing. 0.4 under, 0.1 under, 0.4 over, 0.1 over. It's going to average out to 60. But I want to find those groups using SQL. And just like before, if I'm looking for trends in my data, I'm generally looking for patterns. And what I've done here is I've said, well, if I look at the delta being how far away from 60 I am, when the running total of delta adds to 0, for example, I was 1.3 minus 1.6 minus 1.3, and then we got to 0 because, as we saw, those 4 rows had a sum delta of 0, then yeah, I actually had a good set of 4 laps in this case. The pattern matching query does that. How many times am I off target with my deltas, and when did the sum of the deltas end up 0? Then that classifies as a match for me. So laps 1 to 4, I averaged at 60 seconds. And as we saw before, laps 9 to 12 also averaged at 60 seconds. But this is the reason it's not so good just to rely on your own eyes when it comes to analyzing data, and that why SQL is generally going to do a better job. If I look at my data again, in fact, I averaged 60 from 2 down to 10 as well. So a broader range also gave me an average of 60. One of the things I can do with Match Recognize is I can tell the database to actually start looking for fresh patterns immediately it finds one pattern from the very next row. So it said, yep, from 1 to 4, you had an average of 60. From 2 to 10, you had an average of 60. From 4 to 10, you had an average of 60, and so forth, and then the 9 to 12. So as we can see, using SQL has revealed some more interesting patterns that I simply didn't pick up when I was using my own eyes. The weekend comes to an end. Because I've been driving around to all those sports, I of course have to start thinking about filling up the car. And I'm sure it's the same in Latvia as it is all over the world, is petrol is not cheap at the moment. It's mind-bogglingly expensive. And as a result, I generally don't refuel the car every single day or every single week. I try to do it on select days because here in Australia, on certain days we have discounts. As a result, it's not a case of fill my car, run it to empty, fill my car, run it to empty, etc. What I tend to do is obviously at the very start, it started off as empty, the car was percent full 0, and I filled it up with 45 litres. I came close to filling it with 45 litres. But then I waited, and when it was a discount day on the 9th of August, even though the car was still 20% full, I still put another 37 litres in because that was a cheap day. Even on the 13th, the car was 60% full. I still added some litres because it was a cheap day, etc. So it's not a case of running the car down to zero every time. I'm generally going to go to the petrol station every time I see there's a discount day and sort of try to keep the car regularly topped up. I thought that was a very smart approach until I read the owner's manual, which told me that no, that's important for a sports car to have nice clean fuel, and that you should generally try and get the car close to empty to get rid of all the impurities and add a fuel cleaner and all this kind of stuff. And they even gave me a little spreadsheet to let me know how to calculate how many impurities are in the fuel tank. And it said, if the car is empty, then the amount of dirt or impurities you're going to have in there is about 5% of the number of liters of fuel you put in. So I can calculate the dirt for an empty tank. If the car is not empty though, then what I need to do is said, well, you need to take the previous amount of impurities in the car from the previous calculation and then multiply it by how the percent full the car is, and then use the same calculation to pick up the new fuel you're putting in. That's this liters 0.05. That's easy to do in Excel. It's a bit problematic in SQL because I don't know the result of this calculation. I can't work out this one until I know the result of this calculation. To work out the dirt here, I can work out the dirt from there, but I don't know how to work out the next result until I've actually calculated the first one. It's a recursive relationship. And it seems to be, how do I do recursion in SQL? It's actually possible. First of all, I need some sort of nice logical ordering system to my rows such that I can easily relate one row to another. So I'm simply going to use the row number analytic ordered by date, such that even though these dates have gaps in them, I can now have a nice logical sequence. That's the first row, that's the second, etc. Let's now, using that input with a with clause, as we saw before, I'll use that to build up a recursive relationship in SQL. Now, like recursion, we have a rule that iterates over recursively, and we have an end clause, or we have the reverse. We have a starting rule, and then basically we can come up with a way of how we iterate forwards. And that's how we do it with the with clause. I'm going to have a with table now called results. It actually takes parameters now, and you'll see why they're important in a second. I need a starting position. The starting position is that first row where sequence equals 1. That's going to give me my initial calculation of the impurities in my fuel tank. Once I've done that, I now need a recursive relationship. How do I take that first row and use it as an input into subsequent calculations? So this results table has the first row, and here's where things get interesting. The subsequent calculations say, take my row from T and use the input from the results table. That's the recursive relationship. Here I have a results table that refers to the results table. How do I make that linkage between one row to the next row? I'm simply saying, take the current row minus 1, that's going to be the previous row from my results table. And then I do a query. You can see that recursive relationship. It's a table that refers to itself, and I get my dirt calculations straight out of there. It's recursion in SQL. You can think of it as a much more flexible and powerful version of the normal the connect by syntax that we've had in Oracle since version 2. Now, the average person that looks at an Excel spreadsheet and you say, you could rewrite that as a recursive SQL, says, I like Excel spreadsheets. They like using the familiarity of formulas in Excel. If they like that, but you want to give them the power of SQL, the processing power of an Oracle database, because let's face it, an Excel spreadsheet is going to cap out at, 1 million rows. Well, you can actually give them expressions in Excel-like expressions in SQL. I can take my source data here and I can tell the database to, let's call it, transform it into an Excel spreadsheet. What does an Excel spreadsheet have? It has something that identifies each individual row. That's what we call dimensions. I have something that identifies each individual column. We call them measures. Once I've defined my dimensions and my measures, I now know how to map the data into Excel-like cells. And then I can use those kind of Excel-like expressions. I can simply say, right? Here's my expressions here. I have order by sequence, which goes down here. And I have, for example, the dirt for any particular cell, any one of these cells, is the dirt for the previous cell, effectively, times the percent fill. Here we have the liters, etc. It's not one for one, but you can see it's very close. These orders, these formulas here are very close to the formulas we put in Excel. It's not a great jump for someone to make that transition. And we get the same results back out. Let's wrap it up because we've got just a little bit of time left for a bit of Q&A, and I don't want to impinge upon the next session, which will be some upgrade goodness with Mike and Daniel, etc. I've referred to this session as being modern SQL, and I have to concede it's really a bad title. I hate to say it. It's really just about intelligent SQL, because what we've spoken about today, to be totally honest, isn't all that modern. Let's go through quickly what we spoke about. Grouping sets, row numbers, analytics. They've been available in the Oracle database for 23 years. They came in Oracle 8i. In fact, I tell a lie, grouping sets came in 25 years ago. The other two came in 8i release 2. So yeah, 2 decades those facilities have been available in SQL. Partitioned outer join and the with clause. Oracle 9i, 20 years ago, 2 decades ago. So for 20 years, you've had those facilities in the Oracle database. The model clause came in Oracle 10G. It's been around for 18 years. So yes, while all those versions of the database are well and truly out of support, you can be pretty confident that those SQL statements have been tried and tested. Recursive with sounds breathtakingly new, doesn't it? 12 years, over a decade it's been around. 11G release 2, the recursive with statement came in. All that pattern matching gobbledygook you might have just seen. 7 years, and it is an eternity in technology terms. That came in 12C release 1. It's funny, I know numerous customers that literally upgraded from 11 to 12 solely to get the match recognized facility, because for data analysis, it is just gold to business intelligence people. Probably the only one that we can actually say is new is SQL Macros, which have come in Oracle 19C. They've been out now for a year and probably the least used, but still, hopefully you could be impressed with the kind of flexibility and power. I think SQL Macros are going to be probably a real game changer in the sense that if we think about analytics back in 8i, when we had row number, window functions, dense rank, all that kind of stuff, they sort of sat quietly for a while and then they just exploded with use cases. I think SQL macros will be the same. As people come up with more and more innovative ways to exploit them, I think we'll start seeing some incredible stuff with SQL macros. But I suppose the point I'm making is none of this stuff is new. It's robust. It's tried and tested. Any bugs that were there, they were fixed a decade ago. It's incredibly powerful and flexible stuff. And most importantly is the more power you get into each SQL statement you write, ultimately that means less code in your application. We saw with some of our partition data join stuff, it means that we're simply taking results straight from the SQL statement and rendering them directly on the screen, as opposed to doing a lot of re-rendering and reinterpretation code on your 3GLs. Less code means faster, more maintainable, more scalable applications. That's the key thing here. And if you're thinking, oh man, if these things have been out for 20 years and I don't know about them, I've missed the boat, I've fallen behind, I'm legacy. It's never too early to start getting into SQL. This is my son, Max. Take a picture taken 15 years ago. He was the first one that was playing basketball now. He's now 17, but when he was a toddler, we got him very into SQL very, very early on. You can see he was a studious user of Oracle SQL. So now it's your turn. If you're thinking, yeah, I want to be able to try some of this stuff, there's heaps of tutorials and useful information out there. If you go to livelabs.oracle.com, there are heaps of various SQL tutorials there where literally you use your free autonomous database. There's guided tours. You simply install the sample schemas and you're off and running. You get to play with some very guided tutorials. If you're totally brand new, if you're just into the Oracle scene and just into database development, head over to bit.ly.database-for-dev. Just keeping an eye on my time here. We've got a complete walkthrough, the beginnings of what is a database table, what is database design, all the way through to how to write SQL, how to write complicated SQL through to analytics and onto pattern matching, etc. If you want a place just to play with SQL and pick up heaps of pre-written tutorials on these features, go to livesql.com. And as a general thing, people often accuse Oracle of being, oh, that's the company that charges for everything. If you head over to developer.oracle.com/free, literally there is page after page after page of totally free resources, free databases, free servers, free tutorials, free Dockers, free images, free everything. So many facilities there that cost you absolutely nothing to get up and running and improving your Oracle database skills. That's me done. I'll leave up the bio information there once more. Please reach out to me on Twitter, follow me on Twitter, and hopefully we can continue these conversations even though we live on different sides of the world. Let me stop my share. And hopefully, and most importantly, we'll all be doing these kind of tech conversations face-to-face in 2022. I hope to see you some stage face-to-face, hopefully with a beer or some other beverage in our hand, and hopefully exploring some of the wonders of Europe. Thank you very much for having me. I'll hand back now to the hosts. If you have any questions, you can put them here or send them to me on Twitter. Love talking tech. But for now, thank you very much, and I'll hand back to our hosts.